So here in this class, in this part of the NBC 2.1.9, it is about explained about plumbing portion. Okay, here the pipes, the fixtures and other apparatus inside a building for bringing water supply and removing and waterborne waste. So all these things, as usual, it's called as plumbing portion. The installation of the foregoing pipes, fixtures and other apparatus. So these are also comes under the plumbing only. Foregoing pipe fixture means what? Rainwater removal. Okay. So here plumbing system. What is this plumbing system? Shall include water supply and distribution pipe. Both water supply and distribution pipe, plumbing fittings, traps, soil, waste, vent pipes, okay, anti-siphonage pipes, building drains, building seviers, including their respective connection device. So all are coming under plumbing system. In this section 3 general, we are going to see some basic parameters, basic principles. First one is potable water. All premises intended for human habitation, all premises intended for human habitation, occupancy or use shall be provided with supply of potable water. Okay, this water supply shall not be connected with unsafe water resources or shall it be subjected to hazards of backflow. Means what? A potable water means it should not be connected to unsafe or backflow. Okay, so every human should get potable water. So water provision means what? Plumbing fixtures, devices and apparatuses shall be provided. Apparatuses shall be provided with water in sufficient, and at pressures, adequate to enable them to function properly and without undue noise and under normal conditions of use. So water provision means how you are providing water, how much volume you are providing, how much quality of water you are providing, so that it is totally functioning properly, that system is functioning in a proper way. Okay, there should be at least a residual head of 0.018 Newton per mm square pressure. Okay, so at the customer tap, so that much pressure is there. Water conservation, it should also give water conservation. This one, plumbing system shall be designed, installed, adjusted to use the optimum quantity of water, consistently with proper performance and cleaning. So water should not be wasted here. Okay, the system should be designed, installed, okay, adjusted to optimum quantity of water. Means suddenly in a scarcity way, so you should get at least a minimum water for using. Safety devices. What type of safety device you can adopt here? Plumbing system shall be designed and installed with safety devices to safeguard against what? Dangers from contamination, explosion, overheating. So what type of safety device? Give example for contamination. For contamination, to avoid the contamination, you generally go for scur walls. For controlling the explosion, you go for relief walls. For overheating and all, you go some pressure relief extra taps. Okay, pressure relieving extra taps. Plumbing fixtures. What type of fixture do you expect here? It is recommended that each family dwelling unit should have at least one water closet. You should have at least one water closet, one lavatory and one kitchen wash place or a sink and one bathing wash place or shower to meet the basic requirement of sanitation and personal hygiene. These are minimum thing. One water closet, one lavatory, one kitchen wash place or sink, one bath wash place or shower. Okay, these are main principle for control the sanitation or as well as personal hygiene personal hygiene. Okay. Drainage system. What about this drainage system? The drainage system shall be designed, installed, maintained. Shall be designed, installed, and maintained to safeguard against what? Fouling, deposit of solids of similar studies. Okay, in India, the curves based on Hunter study may be followed. To design this drainage system, some Indian what is that? Similar studies have to be conducted, or the curve design charts from the Hunter. So this is mentioned in codebook. Okay, it's mentioned in codebook. So such that fouling should not take place. Fouling means what? Of the bad smell coming out of the things. Pipe size computation. How you should compute pipe size? Commercially available standard size of pipes are only to be used against the sizes arrived by actual design. Okay, whatever actual design will give the discharge pipe size, no? So to install that one, what are the commercial sizes available? If little bit more is also there, then you can go for that one only. Okay, how to get the pipe size? Therefore, several empirical formula are used to calculate this design, even though they give less accurate results. So little bit okay, no problem. Accuracy is not there also, then you can go for the further things. Factor of safety is all there. This is one table. This is one table number 5 from NBC codebook. What it is telling? Probabilis simultaneous demand. How much water should be there? How much water should be there for a customer point? So we have main two categories. One is with flush, sorry, systems with flush tanks demand based on fixture units. How many fixtures are there? No, fixtures means number of times, number of using points. So it is called as based on fixture units. Here after Hunter means what? Here he has done some design part according to him what is the required. Here two columns are there. Unit rate flow, flow in liters per minute. So two categories are there. Unit rate flow per one fixture, what is that one? Flow in liters per minute. For total, how much is one? If the number of fixtures are 20, these are the values. If the number of fixtures are 40, these are the values. So depending upon the fixture units, number of points where you are using points, you are using the water, no? So they are called as the number of fixture unit. So see all bathtub also cannot be the same quantity. Okay, so those are all things are converted first, converted to one standard one. Later on, one common factor is there, that is called as number of fixture units, the standard fixture units. Okay, so so all those things are, this is table represents what? Probable simultaneous demand. Now if you go to distribution in multi-story building, what are the methods of distribution? We will see. There are four basic methods of distribution. Okay, in multi-story building. Direct supply from mains to taps. Direct supply mains to taps and kitchen, water closets, and urinals supplied from overhead tank. Okay, two things are there. Direct supply to taps and kitchen points, and another supply will be there from overhead tank, which is for water closets and urinals, which is there for water closet and urinals. One type of distribution system in multi-story building. Fixed question from the exam point of view. You understand this one? Okay. Direct pumping system. Here it is, in the first case it is getting collected from the main lines. Here direct pumping system means pumps are used in between. Okay, pumps are used. Next one is hydro-pneumatic system. It's called as hydro-pneumatic system, where some pressure vessel is also included. Pressure vessel is included to boost the pressure of the pipe, to boost the pressure of the water flow. Okay, that is why we call it as a hydro-pneumatic system. Additional to normal pumps, one extra pressure is used. Pressure vessel is used. Overhead water tank. Okay, so first from the pressure main, it is directly going to the overhead water tank. From there the points are collected. In this direct supply system, this system is adopted when adequate pressure is available round the clock at topmost floor. Okay, you understand this one? In this direct supply system, it is when pressure is adequate, full adequate around the full 24 hours, then this is used.